Hello everyone. Today, let's learn how to use Python to solve mathematical problem. Okay, here is a math problem. Leonardo loves prime and create Q queries where each query takes the form of an integer n. For each n, count the maximum number of distinct prime factor of any number in the inclusive range 1 to n. Recall that a prime number is only divisible by 1 itself, and 1 is not a prime number. Okay, that is the question. I give you an example. When n equals 100, you need to check all the numbers actually from 1 to 100, how many distinct prime factors they have, and you return the maximum number of prime factors of any number between 1 and 100, and that is the task. The first thing you may think of maybe just to try and error when just brute force check all the numbers between the given one and the given number and check how many distinct prime factors they have and only keep the maximum number. That will take a lot of loops for a while, whatever the loops is, and will run out of time. And for bigger numbers, it will be really difficult. I spend a lot of time to check, which is not this question asked. Now, this is, after all, a math problem. So we need to use mathematical method to solve this. So think about this question in another way, another approach. So, for example, how many distinct prime numbers do we have? And what is their product? Think about this way. When n equals 100, how many first prime numbers multiplied together is greater than 100? The first prime number is 2, the second is 3, then we have times together because 6, then we times 5, then we have 6 times 5 is 30, the next prime number is 7. So 30 times 7 is 210, which is beyond 100. We don't need 3 distinct prime numbers multiplied together to go beyond 100. Therefore, the maximum distinct factors we can have within the numbers from 1 to 100 is 3, actually. This is a similar question of asking what is the minimum amount of people in the same room which will have at least 2 same-day birthday in a week. The answer is 8. Because there are 7 different days in a week, so we need at least 8 people to guarantee there will be at least 2 people have the same birthday on the same weekday. So this is the same question, actually. Same logic. How can we solve this problem? Now let's start coding, yeah? Okay, so instead of checking all the prime numbers, we just give a list of all the beginning prime numbers starting from 2, 3, 5, 7, 11, 13, 17, 19, then 23, 29, and 31, 37, then 41, then 43, then 47, then 53. Then we can finish this list. Why? Why don't I need to continue with this writing? If you check the question restraints, it says here, so n is between 1 and 10 power to 18. If you multiply all the prime numbers in this given list, you will find out that it's already beyond 10 power to 18. But if you don't use the last prime number, 53, then you will have the number less than 10 power to 18. So the last number is important, and we only need to write to 53. So that is a trick of this question. Now we can tell a very special case. If n equals 1, then we need to return 0 because remember 1 is not a prime number, so it has 0 distinct prime factor. And what if now, before we said if, we need to initialize a product variable, so p equals 1. So make p equals 1, which we use as accumulator of product. If we use accumulator for the summation, then we need to initialize to the value of 0. But this is a product, so we initialize this variable to the value of 1. So that is important. We need to set up a for loop. Okay, so for index I in range, since it's function, we need to use the round bracket in range of what? In range of length of this array, actually, which is a prime. Bracket, then prime. Now this gives us an index variable running from 0 to the length of the array take away 1. So if we use this index variable, we can access each element in the array, which is the whole point. Now we need to multiply the accumulator with the prime number in the list, which is prime I. Okay, that is the accumulator. Now after we multiply p, which is the accumulator, with each prime numbers in the list, we need to make an if statement. So if p, this product, is greater than n, the number is given like we discussed the math problem before, then we can return the value of I, which is actually the number of distinct prime factors to this question. Now let's run the code to see if it's success. Yes, says congratulations. So when you have 6 inputs, 1, 2, 3, 500, 5,000, and very big number, then my output is the same as its output. When we submit the code, you can see all the test cases are successfully compiled. All the cases are successfully compiled. Then you can start your next challenge. I hope you understand this question. Well, this is actually a math question, and we need to learn the problem first, solve the problem using mathematical method first, then tell the computer how to do it its way. And it's very quick in calculating big numbers, and we usually can only handle small numbers. So I hope you love this video, and see you next time. Bye.